actually start streaming for it to stream. There we go. Okay, I think everything's right now. Okay, let me know if it's not. We'll go from there. Okay, welcome on in. I thought I had turned it on 5 minutes ago, but apparently not. Apparently I didn't actually hit start streaming, so sorry for the delay for those of you who are waiting for it. Give people a minute to kind of come on in here. Oops, here's my pen notes. Okay, so where are we at? So your questions have been submitted, right? I had students asking me questions, follow-up questions on Tuesday, and figuring out, okay, how can we do this right? So hopefully everyone's got their questions submitted and is happy with their questions, because unless you get a hold of me immediately, the questions you posted, that's the form they'll be in for the survey. And I think by and large, people are going to be happy with their questions. They're going to be able to progress through their survey productively. That's good. I will probably today, I will try to put that survey together. So possibly today, but sometime in the next few days, I will post a link to that survey, and it will show up here under where it says take the survey, right here. So at the end of chapter 2, if you go in right now, you shouldn't be able to see this because I have it unpublished. But when you go in there, I'm basically going to have a link to the survey. You'll go into the survey and you'll take the survey. And it's really, I'll give you like a week or something to get that done. But there's a couple things about that. One, I don't want to give too long because one, it's just taking a survey, right? It's not like you have to study and really like work that hard. You're just answering some questions about yourself. So, you know, that it's not like you need that long. Like I say, I'll probably give you till mid or late next week, something like that. Maybe not quite a week. But it's really important that everyone does it, because one of the things we're going to learn about statistics is that all things being equal, right? Because with statistics, there's a million different things you can change. But assuming that everything else is being done properly, a larger sample size is almost all of the time better than a small sample size. There's a few instances where if your sample size gets so large that it starts to be like most of the original sample set, in certain conditions that can actually throw things off. We're not going to have to worry about that in this class. So in other words, what we want is for all of you to respond to the survey, because this class is only 40 people. That's not a super huge, and we've probably lost a couple people by now. That's not a super huge sample size, right? That's a rather small n. Remember, we use lowercase n to represent the sample size. That's not huge. So if all of a sudden we have a significant portion of the class not take the test and our sample size goes from like 38 to like 27, you've just lost a significant chunk of your sample size, and it's going to make it harder for everyone to do this. So you just want to remember, you're all in this together, right? We sort of live in a society that is more about like every person for themselves and, you know, sort of move ahead and forget about everyone else. We don't want to have that attitude in here. We want to remember that you don't get points for taking the survey because it doesn't track you in the class. But you have to realize that other people taking the survey is helping you be able to do your project. And so you in return should take the survey because that helps them be able to do their project, right? In other words, if we can get every single one of you to actually take the survey, even though it's not points on your grade, you're doing a service for your fellow human being, right? You are helping them out in the same way that they are helping you out. So even though there's not a reward, there's not a carrot at the end of this, just chalk it up to doing a good thing, right? You're being a good human. You're following that rule that says, help people out the way I want them to help me out, right? So it's really important in the next week or so. maybe a little less than a week, that you get in and take that survey. The reason I don't want to wait longer than a week is because once we have the survey results, that means you can actually start working on your project, right? Once I give you the results back, and I'll talk about them in class, because that may mean we have to wait, because I don't want to release the results until I see you in class. Because I have to explain a few things. Otherwise, you might move ahead and start doing work and then realize like, oh, I actually did my work on the wrong question and stuff like that. So I'll explain what you should do with the results when you get them. But then you can start working on stuff. You can go in and you can start looking at your questions, and you can measure the central tendency like we talked about last time. Mean, median, those are the big ones. There's a couple little small players in central tendency, but mean and median are actually, really big. Today we're going to talk about measures of dispersion. The big one is standard deviation, but there are other measures of dispersion that are important as well and can be useful. The heavy hitter is standard deviation. And then all of this stuff you can go through and you can start applying it to your project, right? Not actually making your video yet, but getting in there and prepping the work, and all that work you do now for these end assignments at the end of the project or the end of the chapters. The more work you put into those now, the less work you'll be doing in the last week of school. And, if you ask students and professors, I think they'd all largely agree. Which week are students busier in? Is it week, what are we in, like week 5? Are students busier in week 5, or are they busier in week 17? They're busier in week 17, because in week 17, you're going to be trying to finish up your project in this class, right? You probably have a big semester-long essay that you've been writing for English class. You might have a big essay, or sometimes like a written exam, like a test essay for history or something like that. So you have to do all your reading so that you can show up and write the essay in class in your blue book, or however they handle it these days. You're going to be very busy in week 17. So the good news is, if you put in the effort now, right? It's like my thing. I always go back to procrastination. If you put in the effort now to do a really good job when you're doing your visuals and you're doing your analysis and you're summarizing your questions, you're making your connections and your hypothesis tests and confidence intervals, if you're doing a really good job with those throughout the semester when you're supposed to be doing these at the end of the chapters, that means in week 17, when you go to make your video, you're like, oh, I've actually done all the statistics already. All I have to do now is make a video and present it. And remember, I'm not super strict about video production. I don't expect that too many of you are, amateur movie directors and stuff like that. Is probably not something you're super comfortable with. But most of you are comfortable enough with technology that you can use your phone, or, I see people use their phones, and that's legitimate. I'll talk more in detail about it towards the end of the semester. People use their phones. People use, there's free programs for screen capture software. So people make their videos that way and then just do a voiceover. So lots of ways you can do it. That won't be a ton of work if you've already done all the math, all the statistics before that end of the semester. So, there's kind of two approaches. Like, so say at the end of chapter 3, when people get to these project visuals, some people will do an outstanding job. They'll do like basically 100% of what they need to do here right now, and then they can basically be done with that. Some people come in and just do enough project visuals to get credit and go, I'll do a better job later. But then in week 17, they figure out, I'm way busier than I thought. I guess I'm just going to have to do the kind of halfway decent job I did a couple months ago. I'll just use that. And then guess what? Your project is not as good as it could have been. So make sure you're talking to your group members. Learn from your group members. If you figured out something they didn't on how to do something well, share it with them, right? Share it with each other. Have those conversations. Again, those conversations they help all of you, right? All of you are being benefited by having those conversations, sharing what you learned, helping the other people figure out how to do things well. You all benefit from this kind of behavior, even though, again, it's not marked by like points. Oh, if I don't share this thing with my group, it's not going to cost me any points. Right, but it's kind of about being a good human, right? So you can just get that feeling knowing like, oh, I helped some people today. I showed them something they didn't know, and they're a little better off because I helped them, and then they helped me, and I'm better off because they helped me, right? That kind That kind of attitude is helpful. But we can't move forward. You can't move forward with any of that until I release the results from the survey. And I can't release the results from the survey until almost all of you have taken it. So it would be really good whenever I set the due date, if you could really make a commitment to get in there and make that. Usually I have to come in a few times and like push the class. Okay, more people need to take the survey. There's still some of you, I can tell you're in the class because you're doing homework, but let's say we have 35 people still doing homework regularly, but we have 26 people who have taken the survey. That means 9 of you have let your classmates down, right? 9 of you are sort of not pulling your weight properly, and then I kind of have to push, and we slowly get there. It's better if I just say, take the survey by this date, and then everyone does it, because then I can open up the results, and you can start organizing your project, right? Otherwise, if you're procrastinating on that, you're actually costing your classmates a week that they could be prepping their project, right? And there's plenty of weeks left, but some people want to get in there and start working on it and go, I kind of have a slow week this week. Why don't I work on my project a little bit? It's good to let them do that. So just try to, have that sense of responsibility. Even if something isn't necessarily translating into points, you just go, this is my chance to be a good human and be a part of a group and help things move forward in a good way. Okay? So try to do that. So just keep an eye out for that. That survey could pop up today, maybe in the next couple days, something like that. We'll see. So, but just be aware, and it's going to be right here at the end of chapter 2. I'll probably make an announcement when I do it, because it's really good if we can get more of you in there and get that done. What I will also say is about the survey is some of you, I haven't looked at all your individual questions yet. I've helped many of you with your questions, but I haven't seen every single question. Some of you are going to realize that you wrote a question in a way that just isn't going to work. So that's not great, but that's okay. What I'm going to say is the questions in the survey, there's no ownership of the questions. So if you recognize a question, go, oh yeah, that's my question. You don't really own that question. Students can use any of the questions from the survey. So if you start working on your project and you and your group are like, we messed up how we asked these questions, and it's going to make the project really hard, feel free to transition to some other questions in the survey. In other words, you can use other questions that are in there. If you ask some questions, like usually there's more than one group that asks about fitness, right? So let's say you did some questions on fitness, and then some other group did questions on fitness, and you're like, ooh, this question they asked, this would work really good with our survey. If we included this question, we'd be able to say some interesting things. Go ahead and use it. Okay, like I say, there's no ownership of the questions. Most of the time, people end up using their own questions, but I've also seen where people go, oh, this group was really on point. They asked a couple of questions that would be helpful to us to use. Go ahead and use those questions then, right? Some groups have had to completely abandon all their questions, pick a new topic, and use other questions from the survey. That's okay as well, right? And one thing I want to let you know is the project at the end of the semester, I think I've said this, but I just want to make this totally clear. The project at the end of the semester is not a chance for you to show me that you are professional statisticians ready to walk into the world and do stats at high-level think tanks, because you won't be. This is an introduction to stats class. People who have degrees in statistics take years and years of just stats classes, right? So what you will leave this class with is a basic statistics understanding. So I don't expect when you turn in your project at the end of the semester, what I'm not looking for is like publishable work that is bulletproof and perfect. What I'm looking for is, did this student learn? Did this student learn some statistics over the course of the semester? And do they have a better understanding of statistics than they did when they started? And I mean, I don't mean better like you're just marginally better. Like, did this person learn the topics? Do they actually understand a hypothesis test, or did they just memorize how to do it? That's something that is hard to find on an exam. Like when I grade people, when I put a hypothesis test on the test, or hypothesis test on the exam, there are students who just memorize what to do, and they memorize what their conclusion should be. But if you ask them, Like, this has literally happened where we work on stuff in class. The group will say, yeah, we got this one. And I'll say, okay, can someone explain it to me? And they go, no. But I can tell you that what our p-value was, and I know the phrase I'm supposed to say when our p-value is above our comparison value. I've memorized that, so I know what to say. But do you know what it means? No, I have no idea what it means. But in a presentation, it's obvious when a student has memorized the problem versus when a person actually knows what they've just done. They actually understand the steps that they just did. So what I'm looking for when I grade these assignments is, did you learn? So I think a lot of times, the society we live in is so afraid of mistakes. Everyone's afraid that if they make a mistake, that means they're dumb. If they make a mistake, that means that someone's going to make fun of them or ridicule them. But none of that's going to happen in this class, okay? Mistakes are perfectly fine. In fact, mistakes are encouraged, right? When it comes to education, you should be making mistakes. When it comes to math and statistics, you should be making mistakes. There's if you ask people who actually operate at a very high level, they'll usually consistently tell you, like, yeah, you got to make mistakes. If you're not making mistakes, that means you're just sort of sitting in your safe zone and doing things that you already know how to do. You're not really going to learn. You're not really going to expand your abilities. You have to be pushing things. And one of the best ways to do that is to make mistakes, because if you know how to make a mistake and look at it and go, oh, I think I just screwed up. What did I do wrong here? Oh, I see what I did wrong. Now I'm going to do it better, right? That's the whole idea about making mistakes. It doesn't mean you make a mistake, give up, and walk away. That doesn't help anybody. You make a mistake, you recognize your mistake, you fix it, and what did you just do? You just learned something. So I think sometimes students are afraid to put things in their project that didn't go perfectly, because they're like, oh, I messed up on this part, so I'm not going to put it in my project because then I'll look like I don't know what I'm doing. But remember, I'm not grading you on being a professional statistician. I'm grading you on, did this person learn the statistics they were supposed to? And I've had projects where people messed up the survey questions and they own it in the project. They come in and they say, yeah, we asked these two questions, and then when we got our data back, we realized it totally doesn't work, and here's why it doesn't work, and we messed up, so we had to switch to these other questions, and then we realized that this other way works better, right? Because they end up using other questions in the survey. That's great, because sure, that person might feel a little embarrassed that they made a mistake, but what they just showed me was they learned. They said, we did this, it was wrong, we now understand why it's wrong, and we now did better, right? So that's not something you'd turn in you wouldn't put that in your project if you were trying to do publishable research, but you would put it in there if you're trying to communicate to your teacher how much you learned throughout the semester. And you know that's right there. I'd make a note. Okay, yep, they learned something about asking statistical questions. Great, they learned something, right? And then we go on to the next. I listen for the next topic. Did they learn what a confidence interval is? Oh, yep, they just described a confidence interval to me in their survey. They understand confidence intervals. So just keep in mind that's what I'm looking for. Okay, so there's a tendency for students to not want to include their mistakes in the project. But if your mistake, if you learned from it, if it was a learning experience for you, tell me about it in the project, because then I can mark that up and go, oh, yeah, they learned this topic. They know what it is, right? That's what I'm grading you on, is did you learn the topics from the course, not can you get a job with doing statistics. That's not necessarily what I'm looking for. So keep that in mind, and as soon as we get everyone to take the survey, and really you can all help each other out here by taking it sooner rather than later. It's that procrastination thing, except in this case, you're actually going to be holding people back. As soon as I get that survey up, and you can all take it within, try to take it within a couple days. You don't have to get it up the minute the announcement comes up, but if you all take it within 2, 3, 4 days, that means I can open up the results early. And you can, those of you who want to get started can go ahead and get started with it, okay? I don't think I've seen questions from too many students in here in the last couple days, and if I did, I think I responded to all of them. So I'm assumed there's no major questions going on. If there is, feel free to ask in either of the chats, and I can address those questions. Otherwise, we're going to move ahead with the next really important topic in statistics, which is the measure Measures of dispersion. You'll sometimes hear this called spread in a statistical textbooks. They'll talk about the spread of your data or the shape of your data. There's a number of different words that get used here. They all come down to the same thing, and it's important, right? It's actually a really important topic. If you have a question and you have not addressed the center and the dispersion or the spread or the shape of your data, then you are missing some really important stuff, right? As we talked about with central tendency, sometimes you might use the mean, sometimes you might use the median, sometimes you might mention both the mean and the median. So you kind of have to play with it a little bit to think what do you think tells the best story about your data. With dispersion, it's a little bit easier. There's still a number of different ways to measure the shape of the data, but the default is a lot stronger, right? With central tendency, we kind of have two defaults, the mean and the median, and you have to figure out which one to use. With spread, or the shape of the data, there's a strong default, which is the standard deviation, which pretty much, every rule in statistics has times when you should break it, but I think it's fair to say 100% of the time that you have a numerical type quantitative data, 100% of the time you should be using the standard deviation. You might also, in addition to that, use other pieces of information. You might also use the variance. You might also use the range. You might use some of these other tools, but it would be very hard to make a case where you would say, oh yeah, it wasn't a good idea to use the standard deviation for this problem. You'd have to have a really convincing argument why you did not use the standard deviation, okay? And it would be, so sometimes you might use more, but especially at this level for the type of work we're doing, basically, if you don't have the standard deviation in a discussion, or at least that you've calculated it and used it as part of your analysis, then you probably don't have a good reason why you didn't, right? Like I say, every rule in statistics gets broken at some point, but but that's one that I suspect you all should be following. So let's talk about what does that mean. So here's let's start with a picture I've got here. So this is first of all, this is a very poorly done graph, but the picture I wanted to show you is actually in a physical textbook, so I couldn't show you right now. So I found a similar one online. I just want to ask you real quick, we talked about graphs a bit. What's wrong with this graph? There's no labeling, right? This is terrible. Now, this is put inside of a lesson where they talked about everything so much that people would kind of know. I would still argue this is terrible. This is insufficient. But I think the person who wrote this was like, well, we've been talking for like this entire page about what the graph represents, so I think it's still obvious. But my guess is this might be like a student paper or something like that, where they and it was done in Minitab, and so Minitab's an old software, so and I'm not super familiar with it. It might be harder to do good graphs in Minitab. So I just want to point that out, because if you turned in a graph like this on your project, you would get marked down for this, because there's no labeling. If someone hands me this, I go, I don't know what this means. I'm about to tell you what all this is, but as far as your projects, don't turn in something like this, right? There should be down along the bottom. It should our x-axis should be talking about wait times, and then over here it's the y value is the number of people. So for a dot plot, right? Then you would know. So don't turn in something like this, okay? With that said, let me tell you what this represents. This is bank wait times. So wait times, they kind of did this in like the late 90s. Places changed how they had waiting done. And part of this was done because that's when they started moving to more automated systems. Banks started trying to use more machines and less humans. Grocery store aisles, you know how it is. You go to the grocery store at the busy time and the aisles back up, or the wait lines back up to the aisles, and then you can't get through. You're like, I want to get over there, but there's like 3 lines of people in the way. I can't get over there. So people started looking at wait lines and what can we do about wait lines and what is the most efficient and best way to have wait lines. And this is a perfect example of how people will sit around and say, who cares about math and statistics? I don't need that in my life. Well, there are things you can do with it, but if you're ignorant of math and statistics, then you don't know when you can use it, right? That's part of the thing. It's like, most people kind of know they can read, but they know why reading is important. But like you wouldn't die if you couldn't read, right? You would still eat and you would still have shelter and stuff like that. But you can imagine you would a lot of times be doing things the wrong way because you miss out on things when you can't read, right? It's the same thing with mathematics. It's easy to ignore it and say, I don't really need mathematics in my life. But if you don't know mathematics and statistics, you also don't know when it would be helping you. And this is a perfect example. People don't really think of, we can improve the wait times or at least people's opinions of the wait times at banks just by doing some statistics. Yeah, you could. So what happened was you used to have separate lines for everything. And you sometimes still see this like at the grocery store. Sometimes they'll switch it. Sometimes they have it one way, and then if they're busy, they switch to another way or something. So it used to be at the bank, they'd have these bank tellers. Now when you go in the bank, there's usually like one person in there, maybe two people in there that will actually work with you behind the the little aisle or glass or whatever they have, depending on what bank you go to. And they would each have their own line. And so it became this thing. You'd go in there and you'd get in line, and then you'd always feel like you picked the bad line because you'd be sitting there and you'd look at the line next to you, and three people have gone through that line and you haven't moved a step. And you're like, come on, how did I get in this line? The same at the grocery store, right? You ever see people still write a check at the grocery store? It takes forever, right? People used to always write checks or a lot of people would write checks at the bank or at the grocery store, and they'd wait till everything was totaled. So they'd wait till the end, and then they'd write their name and the name of the grocery store. Do people even know what a check is anymore? It's like a piece of paper. It's basically like an IOU, and you give it to a company, and then they turn it into the bank, and they get paid for it, right? So you can kind of fill that stuff out ahead of time. If you're at Vaughn's, you're at Vaughn's. You can write, okay, it's going to be to Vaughn's. Here's the date. Here's my signature, and you're just waiting for the amount of money, right? Well, people would wait, and then it'd take them 5 minutes to write out their check, and your line is like not moving, and you look at the other line, and you're like, 3 people just went through there, like super fast. And so what would happen is people were grumpy about waiting in line. It was like kind of a big deal. So a lot of places, and this kind of started in banks, they went from having separate lines for each teller to one master line. So you have one big line, and you kind of see this more now. They have this at especially big stores. Fry's had this back when Fry's was a thing. Is Fry's gone? I think Fry's is gone now. Fry's, you see this at banks more often. You see this at a lot of places where you wait in one big line, and then when you get to the front of the line, you stand there and you wait for the next available person, and then they call you over, right? There's someone will say, oh, the next person over here, please. So do you see the difference between those? You might have 4 checkout people. In the old days, you'd have 4 lines for those 4 checkout people. Now you have one big line, and the person calls you over, whoever's next. So the question is, which is better, right? Which is better? When you're standing in that line, you might have an emotional feeling about what you think is better, but that's not, in statistics, we're not measuring emotions generally. You could say you're measuring satisfaction, but we're doing it in a scientific way. We're doing it in a numerical way where it's not just, I felt like I was in the wrong line and I'm super grumpy about it. We're trying to measure these things. So what happened was they went into the banks and they did it 2 ways. They would have one bank, there's different ways you could do this. You could change it on each day, or you could have 2 different banks and measure which one. But you'd have one bank where they had separate lines for each teller. And then you'd have another bank where you had one big line, and the person would just wait, and when there was one available, they'd go to that person. So how would you measure that? Well, what they did was when a person walked into the bank, they'd start a timer, and they'd time that person. And then when that person got up to the bank teller, they'd stop it. That's your wait time. So they would keep track of the wait times for everyone that came in. So you'd have wait times for the people that came into the separate line scenario, And then you'd have wait lines that came in for everyone waiting in one big line. And then you would go to the next available teller. And then what you could do is you could graph it on a dot plot. And that's what these are. And I don't remember what the one in the middle is, but we'll just talk about the extremes. You've got this scenario here. This is for one big line, right? This is where you have one giant line. Everyone waits in one giant line, and you wait for the next available teller. And then you walk up, and that person helps you. This one down here at the bottom, this is a dot plot for, let me see if I can make this a little bigger. Where's my slider? It stole my slider, but that's okay. I think it's still showing up. So this is for one wait line. This is for, at the bottom, this is numerous wait lines. In fact, I need to make it a little smaller because we cut off part of it. So one thing that you notice, what about the measure of center? If we took the mean wait time of these up here, and we took the mean wait time of these down here, we're going to get about the same number, because I would say, looking at it visually, it looks to me like the center of this data right here is more or less going to line up with the center of this data here. They won't be perfect, but they're going to be close enough. It's not going to make any real difference, right? If the mean wait time up here is only different than the mean wait time down here by like 4 seconds, that's insignificant, right? And that's the thing you want to get used to in statistics, is sometimes we measure a difference, but you have to ask yourself, is that difference meaningful, right? If we find that one of these ways of having people wait in line saves 4 seconds, is 4 seconds in someone's day, are they probably going to recognize that and go, I'm tired of this bank. I'm not coming here anymore. My wait times are 4 seconds longer than they were at my old bank. I'm going back to my old bank. That's not going to happen, right? But if you see that one is like 90 seconds longer, yeah, people are going to notice 90 seconds, right? So that's what we call significant, statistically significant, is that, well, actually, that's not true. That's the other phrase. But this is what we call significance, in the sense that it's a meaningful difference, right? It means a difference that we would actually care about. Okay. So if we were to take the mean, we wouldn't notice any difference between this top set up here and this one down here, right? Maybe a tiny difference, but not enough to really care. So, but there's clearly a difference here between this kind of dispersion, this shape of our data, and this shape down here. Those are very different. Here we have, look at all our data is really close together. It's like stacked up. It's all tight. Over here, there's all sorts of people. There's this person that basically walked in and got to go straight up to a teller almost. And then we've got these people over here that took forever. But remember, we talked about outliers. These might be considered outliers. We'll come up with better tools for deciding technically what's an outlier or not. You might consider these outliers, but kind of depends. You don't want to be this person, though. These people are probably very unhappy, right? When they leave, they're like in a bad mood. And they're like, this is one strike against my bank. And if they keep doing this, I'm leaving. I'm leaving and going somewhere else. So the bank doesn't like to see that kind of thing. And the other thing they did when they did this was they asked people, how happy are you with your wait time today? Are you upset about your wait time? Do you think it was fair? Do you think it was reasonable? Like, what do you think? And what they found was, even though the mean wait time of the people down here is about the same as the mean time of the people up here were very happier. Okay, people's responses to how they thought the wait times were very, very much happier up here. Why is that? It comes down to fairness, right? We have this thing in society where, and you sort of learn as you grow up and get older, that the world is an unfair place, but we try to be fair, right? We try to be fair in the way we treat people. We try to be fair in the way that we run a business and stuff like that. These people right here don't feel like things are very fair, right? They're like, I've been waiting for all this time, and look, this person just walked in and got helped immediately. How is that fair? There's no fairness in that. So people like a sense of fairness, even though you can't really ever get perfect fairness. But like, people up here felt like, yeah, I had to wait a certain amount of time, but so did everyone else. We all waited about the same amount of time. See how the data's all pretty close together? Sure, this person might have gotten in 45 seconds before this person, but what do you expect? It's not going to be perfect. Whereas these people are like, come on, this is like 5 minutes while this person like tries to explain their situation to the bank teller, and the person doesn't even seem to know where they are. And the bank teller's trying to explain stuff to him, and I'm caught behind that person. Whereas the other line, this person walked right in and got helped immediately, and then they're on a bad mood. They're all salty about it, right? So, so this is helpful. We're looking at the data. We're looking at the spread of the data, and we're seeing for bank lines, it turns out, they concluded in the 90s, this is a much better scenario to see for your bank line times than this one down here, right? People are not happy in a scenario like this because they feel like they got treated unfairly. So the central tendency is not enough by itself. You also have to look at the spread, the dispersion, the shape of the data. Those are, again, 3 different ways of saying the same thing. So if we jump into Statcrunch, I've used this example before, but I'll just kind of show you what it looks like. Let's say everyone takes the exam and we get a whole bunch of 80s. Everyone gets 80 exactly. Okay, so we got 20 students in a class. They all got exactly 80. So let's see. These people are all consistent. So that's our consistent data. And then we've got the inconsistent data. So that is half the class got 60s. And half the class got 100. Guess I could copy paste, would probably be a little faster, but this is still pretty good. And then, well, I'll probably do a third one in a minute. It might help us see what things look like here. Now, this never happens in a class where you get exactly this kind of data, but it will speak to the point we're trying to make. So let's say I want to make a histogram. So I'm going to go to, let's see, here's my histogram. So watch how this works because you're going to be making a histogram. So you go to Graph, Histogram. I want to build it from my consistent data based on the frequency. That's what we want. I go through, everything looks good, I think. Let's compute it. Here's my graph. It's just 1 bar. It's just 1 bar wide. Everyone got an 80, right? So that's what one of them looks like. Let's see what the other one looks like. So it's kind of weird that it just looks like a block, but just imagine everything fit in 1 bar of our histogram, so we only have the 1 bar. Okay, now let me make one this other way. Let's go to Stat. What's going on? There we go. Oops, graph, I mean. Histogram. Now we want inconsistent and compute, and now we have 2 bars. Because here, everyone got 80. Here, oh, looks like I'm not on screen. Let me resize these. Also, when you're making these, or I'll show you in just a second, but see how we have 2 bars here? See, the shape of this data is different. This one is just purely everyone got the exact same. There's no variation in our data at all. It's all the exact same. Here, we have, well, a bunch of people got 60s, a bunch of people got 100s. By looking at the shape of your data, it will give you feedback as to what is happening. It's really, really important. So that's why basically every time you have a question or a quantitative question, you should look at a histogram of it. You might not use a histogram in your final presentation, but you should look at the histogram and try to ask yourself, what is this thing telling me? What am I learning by looking at this? Okay. And then for those of you who are going to use Statcrunch to make your graphs for your projects, you can go into options and then let's see, it should be edit, and then you can change things by, where is it? You can change your bin size and your width, which is helpful, right? Depending, I highly recommend you do that. If you're doing a histogram, it only takes a second to come in here and try another one. You should probably try at least 5 different histograms. Every time you make one, make 5 different ones where you play around with the numbers and you go, I wonder what this is going to look like. I wonder what happens if I make my bins, the width of my bin bigger. I wonder what it's going to look like if I start at a different point. Although there's usually a more obvious point on where to start. But the width you might want to play around with. And then you'll just, it'll take you less than a minute to do 5 of them. And then you can look at the one and go, oh, this one's really good. I like this one. That's almost always better than just using the first histogram that Statcrunch spits out to you and going, okay, I did a histogram. I can check that off. Try to find a good one. But also you can go in here and you can see we've got x-axis label and y-axis label. So I could say, I could say test scores, and my label could be, frequency. That is the number of people who got those test scores. And my title could be, stats exam 2 test scores or something like that. See how that I'm getting that labeling in there? And you can mess around if you want horizontal lines, vertical lines, and whatever. And you can even get fancy and you can get into having multiple graphs at once. That's great if you're going to do a comparison. So it's up to you how you want to do that. So let's go compute. Now notice I've got I've got my labels in there. So then when someone looks at this, they don't have to go, what is this representing? They go, oh, this is the test scores from a stats class exam 2. This x-axis is the scores, and here's the number of people got them. Okay, I understand. 10 people got 60 on the exam. 10 people got 100. They don't have to ask you a single thing. If someone looks at your graph and has to ask you a question, then you didn't do a good job, is basically, at least as far as interpreting your graph and what it represents, then you didn't do a good job. So see how easy it was to go in and put those labels in there? Just took a second. Don't forget to do that. Okay. So you can make a few of those relatively easily. So when we do, let's do the summary stats on these. Actually, let's see if I can do both of them. No, it'll just do one at a time. Compute. One of the things it gives us is standard deviation. The standard deviation is a measurement of how much your data values are deviating from each other. To deviate means to change or to move, right? So from this first data that we did where everyone got 80s, how much is our data deviating from the other data values? 0, right? There's no deviation at all. They are all exactly the same. Okay, so our standard deviation, our main measurement of that is 0. Now you'll see when you watch the lessons, they'll go more in depth to what standard deviation is, but what you should be thinking of it is standard deviation is measuring how spread out my data values are. How spread out are they here? 0. There is 0 spread to our data in this example. All right, let's try a different one. Let's go stat, summary stats, columns. Let's do the inconsistent. Now I compute. Notice how our standard deviation is not 0 anymore. That's because we have a deviation. We have the data values differing from each other. Half of them are all 60s, half of them are 10s, but there is some spread to our data. So we are measuring that in the standard deviation. Usually when we do this in an on-ground class, I have students go through the standard deviation calculation by hand for a small, simple problem, like 5 data values. And the reason I do that is because working through that, students who are comfortable with mathematics, it actually helps you realize what the standard deviation is measuring because you did the calculation by hand and you go, oh, I see how this is measuring the spread of the data here. It's a little harder to do online, so we'll skip that. But just recognize that. Recognize the standard deviation between these two problems. Was 0 standard deviation means every data value is exactly the same. Once those data values start to spread out, which they almost always do, then this number is going to increase. The more spread out your data is, the greater your standard deviation is going to be. So in this case, it's the number that you come up with is 20.5 for your standard deviation. Okay, if we spread them out even more, the standard deviation would get bigger. We also have this measure of spread called the variance. For most of what we do in this class, the variance is probably not going to play a large role. It will come up. You'll see it in the videos. You should understand what it is, but it's just another measure of the standard deviation that sometimes is preferred to use. It turns out the variance is actually the square of the standard deviation. So if you take this number right here, standard deviation, and square it, you get the variance. But in this class, almost 100% of the time, except when you're specifically learning the variance, almost 100% of the time, you're going to instead go with the standard deviation. Okay, that should be your go-to for measures of spread. So if you have 2 questions, one's really compact. Everyone kind of answered approximately the same, like what is your age? let's just say we happen to have a class where there's no older people in it, it's all like 18 to 22-year-olds, then you'd have a very small standard deviation. But then you ask, how many units are you taking? And some people are taking 3. Some people are taking 18. You're going to get a larger standard deviation in that case. And you could show those. We have very little variation in our age in this class. We have a greater variation in our data for number of units taken or number of hours worked per week, right? Something like that is going to have more deviation. Some of you don't work at all. Some of you work close to 40 hours a week, right? I remember doing that, waiting tables at night and then taking classes during the day. And it's like you sit there and you're like, I'm almost working a full-time job waiting tables. And then I'm trying to do, 12 units of math and science and stuff. It is a lot, right? So and some people, if I remember right, I think that's this class. Some people are doing that comparison, which is the number of units that students are taking and the number of hours they're taking. Or maybe that was last semester. I don't remember. But is there a connection between those, right? How does that work out? So that standard deviation is going to be part of that discussion, which is how spread out is our data? Do all our students work basically the same amount, or do some of them work very little and some of them work a whole lot, right? What's going on there? So that's your standard deviation that you would get from here. Standard error will come up later. It's not going to play a huge role in what we do, but it's kind of important to understand it. Another measure of spread is your range. What your range does is it takes your lowest data value and your highest data value and subtracts them. Remember we looked at min-max yesterday, or whenever it was that we talked about it. The subtraction of your min and max, that gives you the distance over that contains all of your data values. So in this case, the range is 40 because 100, our max minus our min is 40. So that gives us the whole range we need to cover. Notice down here our range is 0 because our min and our max are the same. Usually when you're presenting statistics, you might talk about the range. But the range, I find, is usually more helpful when you're deciding how to make your histogram look good. You're trying to construct a histogram, and you're like, well, how wide does it need to be to contain all of our data values? Oh, it needs to be at least 40. Because if the range of values we come up with our histogram is only 35 wide, well, some data value is getting left out then, right? I kind of like in general to go a little bit more than the range. Like if I was going to graph this for the range, I'd probably put a little buffer on each end. I guess you can't really go over 100, but it looks kind of weird when your data points sometimes are right on the edge. Sometimes it looks okay, but sometimes it looks sort of, I don't know, just visually or aesthetically doesn't look nice. So you might have your range. If your range is 40, then when you make your histogram, you might have the width of the whole histogram be 45 or 50. So that all your data is kind of in the middle. Otherwise, it's distracting if you have points that are over by your labels and stuff like that. But, that depends on how you're going to do that. So a great way to see your spread is to either use a histogram, right? Histogram if it's numerical data. You can use a bar plot if it's categorical data. And then you start to see the shape of your data. Okay, you start to see that shape. Once you know the shape and you know the mean or median, so you know the central tendency and you know the shape, you know a significant amount about your data. You don't know the whole story yet, right? But that's like a big step you take right at the beginning. Calculate the central tendency, calculate the shape, take a look at it, and then you're going to understand it all. That starts you off understanding quite a bit of information. And then we'll get fancier later with confidence intervals and, all that kind of stuff. And then showing people stuff in a histogram, very helpful, right? Rarely do you ever see a published statistical paper that doesn't have some kind of graph in it. Histograms are used a lot. You also see people using, sometimes you see people using the stem and leaf plots, which we'll talk about at some point. And sometimes you see them using numerous stem and leaf plots, and you compare the stem and leaf plots, and that can be helpful. That's a thing that's done a lot. You might do that with like temperatures, and you do temperature for each month. So they might have 12 of these stem and leaf plots all next to each other on the same chart so that you can compare, and you can go, oh yeah, look, January is significantly colder than July, which is what you'd expect, but you can see how much, right? I've lived in different parts of the West Coast. Our variation in temperature is very small. It might seem like it. You're like, what are you talking about? In winter, it's like way colder at night than in the summer. Right, but like when you're in Colorado or Washington, the temperature in August is very, very different than the temperature in, say, January, right? In Colorado, you'd have, you might have weeks in January where like you don't get above 45 degrees or even close to 45 degrees. And then in the summer, it's like 95 degrees. It's like 50-degree difference in your high temperatures over the course of the year. We don't have that here. Our temperatures do not vary by 50 degrees, right? We might be in the 90s as a high in say August. Usually not, usually like below 90, usually like 85 or something here in Ventura. And then in the winter, it might get down to like 65 during the day. So you could see that by looking at numerous stem and leaf plots. But again, it's how much does that data vary, right? You can't just take the mean and go, that tells the whole story. You want to look at the shape of the data and see how that works as well. Okay, so that's what they're getting at in the details in the lessons that we'll be taking a look at. Okay, looks like I'm out of time. As always, I'll shut down the YouTube stream. Anyone who wants to talk to me or ask me questions, jump into Zoom. I will try to get that survey up either today or tomorrow. And again, you're just helping your fellow students and yourself. The sooner you take that survey, the better. I will try to get that up today or tomorrow. So anyone who wants to talk to me, stick around. Thanks, everybody. And I